everyone, let's continue at question number 7. Item 7 refers to the following Venn diagram, which shows the number of members of a sports club who played rugby or basketball. So here we have a Venn diagram showing the subsets rugby and basketball. Okay, so if you notice, these two subsets, they overlap. Now, at the point at which they overlap, that is known as the intersection. Alright, so your intersection consists of elements that are common to both rugby and basketball. It simply means that of the total number of members of the sports club, there are 12 members who play both sports. There are 13 who play basketball, and there are 15 who play rugby only. So for question 7, the number of members who played rugby only would be equal to 15. So therefore B is your answer. Item 8 refers to the following Venn diagram. So if you notice, certain regions of our Venn diagram has been shaded. If you notice, the region outside of both subsets P and Q has been shaded, and also that region which represents elements of Q have also been shaded. Okay, so if you notice, P is left unshaded. Alright, so looking at our options, we have P complement, which means that which consists of the elements that are not a part of P. Okay, so since P is unshaded, it simply means that A is our answer, which reflects all the members that are not a part of P. Moving on to items 9 to 10. So items 9 to 10 will refer to the following Venn diagram, which shows the universal set U and the two sets T and C that represent students in a class who played tennis and chess. So here we have our Venn diagram. We have T, set T, consists of Ali, Alex, Tom, and Kayla. Alright, I think I got that one right. Alright, moving right along. Now from this Venn diagram, it's very evident that Doug, Chaz, and Dora play neither tennis or chess. Now, Ali, Alex, Tom, and Kayla plays tennis only. However, Paul and Rima play both chess and tennis. So this is what the Venn diagram is basically explaining to us. So for question 9, how many students play both games? So remember, we had said that Paul and Rima plays both tennis and chess. Okay, so therefore there are 2 students. So therefore our answer is A. Alright, so let's look at question 10. How many students play exactly one game? Alright, so let us examine this diagram. Okay, so Dora, Shaz, and Doug, they play neither tennis or chess. Ali, Alex, Kayla, and Tom, they play only tennis. Paul and Rima plays both. So remember, the question asks us how many students play exactly one game. So the answer is 1, 2, 3, 4. So therefore C is the correct answer. Alright, moving right along. Now item 11 refers to the following information on the description of 3 sets. So the sets are as follows. We have set P that consists of prime numbers, set Q odd numbers, and R even numbers. But the first thing that we want to do is to ensure that we know what prime numbers are, what odd numbers are, and what even numbers are. Okay, so prime numbers has 2 factors, one and itself. Odd numbers are numbers that are not divisible by 2, and of course even numbers are the converse. Now, which of the following sets is empty? Now, looking at our options here, P intersect Q. Alright, so this would require the elements that are common to P and R. So let's look now. So we're looking at prime numbers and we're looking at even numbers. Alright, so that is one. Examining our options, P intersect Q, so prime numbers and even numbers. So of course, 2 is a prime number and it's also equal, so that set is not empty. P union Q, prime numbers and odd numbers. No, that is not correct. P intersect Q, so that would be prime numbers and odd numbers. Alright, so that set is not empty either. Q, which is odd numbers, intersect even numbers. Alright, so I think that this is the empty set. Alright, so we have no odd number that is also even. So our answer is D. Alright, moving right along. Question 12. If the number of elements in set A is equal to 14, the number of elements in B is equal to 15, and if the number of elements in the intersection of A and B is equal to 6, then the elements of A union B is, alright, so the number of elements in both, well, in A union B would basically consist of the number of elements in set A and also the number of elements in B. Okay, however, we would exclude the number of elements in the intersection. Alright, so we're excluding the elements that are common to both. Alright, now the number of elements in A union B, so it's good practice to write our formulas. And alright, so from the question we were told that the number of elements of A is 14, so I can substitute 14 for the number of elements in A. The number of elements in B is 15, and the number of elements that are common is equal to 6. So therefore I can say that the number of elements in A union B is simply equal to the sum of 14 and 15, which is 29, minus 6. So therefore the number of elements in A union B is 29 minus 6, and that will amount to 23. So therefore our answer is C. Agree or disagree? Let me know. Alright, so question 13. A dress which costs $180 is being sold at a discount of 10%. So please note that a discount is a reduce or a reduction in the original value. Alright, so the dress costs $180 and of course a 10% discount is being offered. The amount of discount is, so that is what we need to find. Alright, so the cost price is simply $180. Now we need to find that 10%. That's 10% that will be subtracted from $180. Now how can we do that? Well, we know that 10% is basically equivalent to 10 over 100. All right, so we can write 10% as 10 over 100. Now what we need to find, 10% of $180. All right, so this can be rewritten as 10 over 100 times, all right, so we're using our language, $180. All right, so at this stage we can cross cancel, so we check a numerator and a denominator to see if there's a common factor. So if we should look at the numerator of 10 and the denominator of 100, we have more than one common factor. But this time I'm going to choose the highest common factor, which is 10. So I can get one group of 10 out of 10, and I can get 10 groups of 10 out of 100. All right. So remember, we're canceling numerator and the denominator. Now, if I look at this new denominator of 10 and this numerator of 180, I can also find more than one common factor, but this time I'll be using 10 once more. So I can get one group of 10 from 10, and I can get 18 groups of 10 out of 180. All right, so when I check my numerators and denominators, I realize that these are the only numbers that are left. Okay, so I will now find the product of the numerators, that is 1 times 18. All right, so in the denominator I will have 1. If I want to change $180 to a fraction, then I would simply divide it by 1. All right, so of course the denominator would be 1 as well. All right, so therefore my discount is $18. All right, so remember now that 18 is not the answer. 18 is the discount. All right, so it simply means that I will subtract 18 from the original amount. All right, so here we go. So if our cost price, or the price on the tag I should say, is 180, and I know that this will be reduced by 18, my apologies. Please accept my humblest apologies. The question asks for the amount of discount. Okay, so my apologies right there. Okay, so the 18 that we have found would be the amount of discount. All right, so the answer would be C. All right, so that is it for this video. So I hope that you understood all the concepts that were being explained. If not, feel free to comment down below. All right, see you in the next video. Goodbye.